Starting out with our bell ringer for the day. 3/5 equals 5/4 x plus 2. Again, this is another situation that we're going to see for the next 2 weeks to give you some time to practice. I hope you're getting better. 5 and 4, you have to find the number where they meet. 4 does not go into 5. It does not go into 10. Does not go into 15, but it does go into 20, which means that our number should be 20. Again, the first thing you have to remember is everything has to get multiplied by 20. Again, keep in mind you then multiply by the top number. That becomes 60 over 5 equals 100 over 4x plus 40. And the last thing that happens is 60 divided by 5 turns into 12, 100 divided by 4 turns into 25, and 40 comes down. And once again, we are at a basic position here where we simply subtract 40, getting negative, I think that's 28 equals 25x, then dividing by 25 and getting negative 28 over 25 equals x. So if you did that right, that's what you should have gotten. If you did not get it right, try to locate what you did wrong so that you can try to get better. Again, the only thing I'm doing in here is trying to get you better with your skills so that you can do fine in all the math you see. But getting into chapter 4, section 2, this section is going to ask you to consider how situations with a linear pattern can be analyzed and used to predict future outcomes. So we're talking about linear patterns. That means that the distance between the two numbers in the pattern is the same. We saw that yesterday, and it looks like a straight line. The main skill of this section is going to be your ability to create an equation and represent a pattern. I believe the best way to do this is to show you a few different situations that you might see first, and then you can write this down if you want, but we still have notes later. But just make sure whatever it is that you understand what I am doing here, because it's really not that hard to do. It's just a matter of again, making sure that you can check and understand this process. What you do is, once they give you a pattern with 1, 2, 3, and 4 as your independent, notice it's just counting up by 1. You look here and you say this is going up 4, this is going up 4, this is going up 4. Again, this is a linear pattern because the change is the same. Now this number is important, and what this number does for us is it tells us what we call our rate of change. And so you take that rate of change times x, because what's going to happen is whatever it is, it should be 4 times 1, which is 4, then 4 times 2, which is 8, then 4 times 3, which is 12, which is a change of 4. The last thing you do is you simply plug this number in here mentally, and you say if I put a 1 in here, that gives me 4. How much more do I have to add to get to 17? And of course it's 13. And if you check it, 4 times 1 plus 13, I'll even get the calculator out here. 4 times 1 plus 13 is your 17. 4 times 2 plus 13 is your 21. 4 times 3 plus 13 is your 25, and so on. So again, you use the difference as your rate of change. That number gets multiplied by x, and then this number represents your adjustment. Okay? So that's pretty much all that there is to it whenever you have a linear pattern. Let's look at another one here. On this one, you notice that we are going plus 2 from 0 to 1, plus 2 from 1 to 2, plus 2 here also, which means that our common difference is 2. So we know that our initial pattern is going to be 2x. Then what you have to do is take this number, plug it in here. Of course, 2 times 0 is 0, and if I want to get to 16, I obviously have to add 16. So I mentally check that. 2 times 1 is 2. 2 plus 16 is 18. 2 times 2 is 4. 4 plus 16 is 20. 2 times 3 is 6. 6 plus 16 is 22. That would be the way that I turn that into a equation. So again, the general steps are not that bad. You just have to make sure that you understand how to use this common difference. Looking at this common difference, we are going down 10. Make sure you recognize that that is a negative 10. Going down 10 again. Going down 10 again. This is a negative rate of change, which is why we'll start off with negative 10x. But here's where you have to be careful. Don't just assume that it's going to be 10. If I put a negative 1 in here, that makes negative 10. How do I get from negative 10 to 35? I don't know. Let's do 35 minus negative 10. And you see that it's a difference of 45, which means that you would have to add 45 to that to make it work. So let's just check. And again, that's the beauty of this, is that you can check it on your calculator. Negative 10 times 1 plus 35 gives me, plus 45. gives me my 35. Negative 10 times 2 plus 45 gives me my 25. Negative 10 times 3, just to check three numbers because usually 3 is a good indicator, plus 45 gives me my 15, which tells me that we're okay. So again, the first thing you have to do is find the rate of change and multiply that number by x, because if that's your rate of change, it should change by that much, and then you adjust by whatever that number is there. So you have to have a little bit of understanding on how numbers work, but again, with a little bit of practice, you'll get better at that. So now that we have that general idea, the rest of the unit is just based on our ability to analyze and interpret the information that is in front of us. So the next set of problems that I work through are going to be in your book, or they are in your book, so you don't need it, but I'm just letting you know that that's where I'm getting them from, because these represent questions that you're going to see. So I'll discuss them. There's really not a lot of notes I can give you. You just have to kind of catch on and replay it and ask questions when you get to that part. But again, this is more of a communication thing than anything else, especially this where it says graph the set of ordered pairs. I'm not going to graph them because I assume that you know how to graph. This would be 0, 0, which is the origin. This would be right 1 up 1, right 2 up 2, right 3 up 3, and so on. The main thing I want to do is talk about the using of the words. So for A, you would say as x, which is your independent variable, increases by 1. Y, which is your dependent variable, goes from 0 to 1, 1 to 2, 2 to 3, 3 to 4, also increases by 1. And that's really all they want to know. So as x increases by 1, because this is your independent variable first, which is always x, as x, which is your independent variable, increases by 1, y increases by 1. Look at B. Here again, your independent variable is going 0, 1, 2, 3, 4, so we would say as x increases by 1. Sorry about that, Mark. Now we look at our y's. Our y's are going 8, 6, 4, 2, 0. Looks to me like y's decrease by 2. Or you could even say increases by a negative 2, because that's the same thing. Increasing by negative 2 is the same as decreasing by 2. Either one of those two things work. C, our independent variable, remains as 3. Our dependent variable 0, 1, 2, 3, 4, y increases by 1. So the good news on the Math XL is that they are going to have options for you to read. Just make sure you read them carefully so you can pick the one that does make the most sense. But in terms of that, that's really all it's going to have you do, is make sure that the graph makes sense, and then they're going to have you pick the answer that works best. Now really what we're here for is 2 through whatever else we have here. It says use a diagram below, copy and complete the table using the relationship between a number of squares and the perimeter of the figure they form. So notice here is 1 square, 2 squares here, 3 squares there, and they have the perimeter of 4 because you go 1, 2, 3, 4. 2 squares has a perimeter of 6, 1, 2, 3, 4, 5, 6. 3 squares has a perimeter of 1, 2, 3, 4, 5, 6, 7, 8. 4 squares would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not going to make 10 squares, and this is why we want patterns. We want to make sure that we have a pattern so we don't have to do 10 squares or figure out which one has 62 and all that. But what we can do now is we can look and recognize that each of these things increase by a factor of 2. And so that means we know we're going to have 2x. So again, now you say this part and you say 2 times 1 is 2 plus 2 more makes that 4. And let's check. 2 times 1 is 2 plus 2 makes 4. 2 times 2 is 4 plus 2 makes 6. 2 times 3 is 6 plus 2 makes 8. 2 times 4 is 8 plus 2 makes 10. So now if you want to know what 10 is, you simply put the 10 in for x. That makes 20 plus 2, which should be 22. If you want to know which one's 62, that's when you use solving. 62 equals 2x plus 2, because of course we want that to be our answer. And then you solve by the means that we learned in our last unit. Did I just do all that? It should be x. I think it's because I was talking. But either way, that would be 30 squares, would give you a perimeter of 62. And then, of course, is there n? Then you just turn x into an n. 2n plus 2 would be what goes there. So again, if you ever see that question, That's what they're looking for. That's what they want you to be able to do. All right. Another problem you're going to see today has different shapes, hexagons, squares, pentagons, anything like that, and they pretty much want you to make your pattern. So the best thing you can do is kind of start your pattern. You have 1 hexagon, 2 hexagons, 3 hexagons. We won't go 4, but that should be good enough. 1 hexagon has a perimeter of 1, 2, 3, 4, 5, 6. 2 hexagons has a perimeter of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 hexagons has a perimeter of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And based off of this pattern, plus 4 here, plus 4 there, we can assume that this has 18. And yes, we could continue that pattern as long as we need, but it helps if we don't have to kind of count all the way up one by one. If we could just go ahead and make the pattern. Of course, since our common difference is 4, we are looking at 4x. And again, this is our rate of change number. Now we need our adjustment number. Take 1 and plug it in here. You end up with 4. And in order to get from 4 to 6, I need to add 2. And so check that out. 2 times 4 is 8, plus 2 makes 10. 3 times 4 is 12, plus 2 makes 14. That would be the formula that you would use to make that perimeter. All right. Not going to do the relation or the equation, but I do just want to kind of make sure you understand. If it says determine if it's linear, just look at the difference. Plus 3 here, plus 3 here, plus 3 here. The answer is yes. And then of course you would do 3x plus something to figure that out. Here, pay attention to the fact that this is not plus 1, it's actually plus 5, because you need 3 steps to get from -3 to 0 and 2 more for that. This is also plus 5. This is also plus 5. So yes, this would also be linear. Here you are subtracting, I believe, 11, subtracting 11, subtracting 11, and because all those 11s are the same, they would again be linear. What would happen is the one that's not linear is something like this, where it's a difference of 1 and then it's a difference of 2. Once you see that different number, that cannot be linear. So again, that's what you're looking at if it asks if it is linear function. Because again, a linear function is going to have the same rate of change no matter what. 11 wants to know whether it's linear, and then it wants an equation to represent it. And so what we will do here is we have to figure out what this difference is. So I'll do 1219 minus 1127. Don't want to do that. And you find out that it's going up by 92. And just to make sure, 1311 minus 1219 gives me 92. And then I hope it's the same. 1403 minus 1311 is also 92. So the first answer is yes, it's linear. The second answer starts from right here, where we're going to do 92x, because if our rate of change is 92, that's what should be attached to the x. From there, you just have to adjust, and it makes it nice whenever we have a 0 there, because 0 times 92 is 0, which means we obviously have to add 1127 to my formula. Of course, that would be y equals whenever you do that on paper. But just to check, 92 times 1 plus 1127, 1219, 1219, one more check, 92 times 2 plus 1127 gives me my 1311, which is there. So again, once you have the general idea of how to take the rate of change number and attach it to x, and then find your adjustment number, it's really not that bad of a section. Last one says make a general table to represent the situation, then write an equation to represent it. Here what I would do is, you're talking about gallons of liquid fertilizer, teaspoons of powdered fertilizer. Represent the relationship between teaspoons of powder and gallons of fertilizer used to make a table. I would base it off of the teaspoons, because of course the teaspoons determine the powder. So I'll put teaspoons here, and I will put gallons over here. And the only way I can really make a table, because it doesn't really tell me anything, is that 8 teaspoons make 5 gallons. And so I have to go another 8 teaspoons, which would be 16 teaspoons, of course, make 10 gallons. And then of course after that you're talking about 24 teaspoons make 15 gallons. Now your rate of change really isn't going to help because this isn't going 8, 9, 10, 11, 12. We have to do a little bit more work. But I do know that we are going up by 5 per every 8 here. So again, look at that. You're going up 5 because your gallons are going up 5 per every 8 there. So that would actually be your rate of change there. Attach an X to that. And then what we have to do is kind of figure out what's going on with that. So 5/8 X, put an 8 in there. And I think we'll just do that in our calculator here. 5/8 times 8 gives me 5. And actually I think that's what I want anyway. And I think if I do 5/8 times 16, it might work the same. Sometimes we get lucky. Notice that's 10. And then you have 5/8 times 24, which gives us our 15. So that is actually our part there. The hardest part about this question is just understanding that your rate is based off of this number. Keep in mind that we said it goes up 92, up 92. That's still 92 over 1, which is still 92 because it goes up 92 here, up 1 over there. We just turned that into a fraction that does not reduce because it goes up 5 per 8, up 5 per 8. So 5/8 would be your rate of change if you happen to have a fraction, something like that. So once again, you're going to log into MathXL and work on answering each of the homework questions correctly. Again, you don't get credit for this assignment till you have a 100%. You have until December 9th to do that. Afterwards, you are to complete the quiz. Again, if you're not ready for that quiz, just go to the C part. Keep in mind you don't have to finish that quiz today, but you do need to finish those quizzes, the B quizzes, in class, because I have to make sure you're in class when you do it. Keep in mind I can check the tag on when you completed that quiz, and if it's not within the range of where you're in the room, I can take it away and give you a 0. So just make sure you're only doing B when you have time in class. If you're out of time, you can go to C and always continue as much as you want and retake it as much as you want, but only take the B test while you're in class. Other than that, good luck today.